Hello everyone and welcome to the second lesson of the School of Solana Season 7 cohort. My name is again Andre, and this lesson is going to be about the Rust programming language, which is the main programming language for the smart contracts or programs on the Solana blockchain. Before we start, I would like to mention one important thing. So for those who don't know, apart from the Discord where you can communicate with us, with the young Tolly, or with another classmates, you can also have a look into the School of Solana repository. You can see the link or you can scan the QR code, and there are all of the materials that we prepared. There are also Docker images that we prepared. So for example, if you are using Windows and you don't want to, or if you have any issues with setting up the environment for the programming of the smart contract for the Solana, then you can use the Docker images, and yeah, they are already prepared for next lesson. So I highly recommend to use them. That said, I think we can continue to the Rust lesson, so I hope you will learn something new, and let's continue.
Firstly, I would like to talk about the Rust playground. So if you do not know how to actually start writing code in Rust, then you can use the Rust playground. If you scan the QR code or if you go to the URL, then it will lead you to the playground of Rust, where I already prepared the Hello World example. But this playground is really helpful if you would like to just test some stuff. So for example, during this lesson, I will show you on the next slides what is the syntax of Rust. So you can test it during the lesson in the Rust playground. I will also include short demo here. For the characteristics of Rust, Rust is designed for performance and safety, especially safe concurrency and memory management. It also offers performance similar to C or C++. For those who know C or C++, you probably know that these two programming languages provide really great performance, so same goes for the Rust. It is strongly typed. Rust can infer types based on the context of the code, but the type system is still strict. That means every value has a well-defined type at compilation time. It ensures memory safety without needing a garbage collector, preventing common issues like null pointers, dereferencing, or buffer overflows. You may also be, again, familiar from the C or C++ with dereferencing, null pointers, or buffer overflows. And it also, for example, provides concurrency without data races. So that means Rust ownership and borrowing, that we will talk about in this lesson, allows safe concurrency, eliminating data races at the compilation time. It is also widely used for example, system-level applications, WebAssembly, or blockchain. So, for example, for Solana. These are characteristics of Rust. If you would like to know more information about the Rust when it started to be popular, I don't think these information are actually really necessary for you to understand it, so that's why I did not include it here. We can go straight to the syntax, so we will start with the basics like variables and mutability. In the code, you can see a few lines. The first line defines the variable called x, which will equal to 5. The second one is really similar, but it also contains the mute keyword that specifies that the variable is mutable. You can see it on the third line where we assign 15 to the second variable. So that's why we are talking about mutability or immutability, and all of the variables are immutable by default. Last but not least, I have specified the constant here called max points. If you define constants, you need to define also type of the constant. So in this case, we define that max points is going to be unsigned 32 bytes long integer. And as the variable is constant, we also need to specify the value. Constants, as the name suggests, are immutable by default. And yeah, I would say this is everything from the variables, how to define them, for example. You can see that we defined the type for the constant. We defined that the constant is going to be unsigned 32 bytes long integer, but you can define the type also for regular variables, not only for constants. Rust can, as I said, infer this from the context of the code, but in this case, the first variable x will be by default signed integer 32 bytes long, but you can specify that you would like to have it as unsigned 8 bits long integer. So similarly to the constant, you can specify also type for the regular variable. Let's now talk about the data types and strings. In Rust, you can have primitive data types. For example, as I was talking about the unsigned 32 bits long integers or unsigned 8 bits long integers. You can have signed 32 bits long integers. You can have floats, both 64 or 32 bits long. We have also booleans, and we have also characters. So I would say there are all of the primitive data types that you can think of, and this is also pretty similar to different programming or to other programming languages. In Rust, we have also arrays and tuples. So for example, you can specify array, which will have 3 signed 32 bits long integers in it. So here's on the line 8, you can see the definition, but we can have also tuples. So the tuple is actually a group of, I would say, multiple variables which does not need to necessarily contain the same type. As you can see in the example on line 7, we have tuple of 3 values. First one is 32 bits long integer, signed integer with the sign, and then we have float and smaller unsigned integer. Then in Rust, we have also strings, which are groupable and heap allocated. That means the space for the string content is stored on the heap, and basically the memory layout is similar to the vector. So the first bytes are reserved for the length of the string, and then you have the string representation. Yeah, but this is just the memory layout. For you to understand, it is enough if you know how to define or declare the string. So on line 10, you can see that we declared string with the content of hello. You do not need to define what's the length of the string. This will be automatically evaluated. And we also define the string as mutable. So that means on the next line, we can actually call a function s.push str, which will actually push the defined part into the string. Then on the last line, you can see we have specified the slice, but you can see the type is slightly different. The type is not string, but it is a reference str, and this str is actually immutable string slice. So it is something like a view into the corresponding string. So if you have the underlying string, like defined on the line 10, you can create slice, which is immutable view on the underlying string. So in this case, we have specified that the slice will contain values from the string starting from 0 until the value 5, or until the index 5, sorry, not value, index. So that means it will include 0, 1, 2, 3, and 4. In this case, if we have a look at the hello, so that means 0, 1, 2, 3, 4. So the slice will be immutable view on the hello word, not the world that's also appended to the string. So hopefully this is clear for you. And again, as I was talking about the playground, you can try this, you can play with this in the Rust playground. Now let's move to the control flow, which includes if statements and loops. So if statements are really simple in Rust, and I would also compare them to the if statements in the other programming languages. We have defined on the first line variable called x, which equals to 10, and then you can have a pretty simple if statement. If x is greater than 5, you will print something. If x is not greater than 5, so if it is equal or less, then it will print different message. But you can also see on the line number 8 that you can assign values from the if statements. So in this case, variable epsilon will have value from the if statement. That means if x is greater than 5, the epsilon is going to be 10. If it's not greater than 5, the value is going to be 0. So pretty simple. I would say maybe just the syntax is slightly different, for example, from the C or C++, where I think you have brackets. But the main idea of the if statements is pretty similar, or I would say the same. Then we have loops. I would say in the loops we have loop which will break when you have break statement. Then you can specify while and for loops. In the while loop, the loop will continue until the condition specified after the while evaluates as true. In this case, we have defined on line 6 that the variable called n is mutable. So again, as I was talking about the mutability and immutability, we can change the value of the variable. It starts as 3, and then while the variable is greater than 0, we will loop. So that means we will print 3, and then 1 is subtracted from the n. So we will loop until n is 0, and if n is 0, then the while statement will break and the execution will continue to the next lines. And then you can see on the line 12 that you can also have for loop, and you can loop in the range of numbers, or you can loop through the vector, through the array, and so on. So these are maybe all right. The for loop syntax is not that similar, for example, to the C++ programming language. But yeah, it is also, from my point of view, pretty simple. So you can loop through the vectors, arrays, range of numbers, and so on. And then last thing I would like to mention in the control flow are the match statements. For example, to the C++, I would compare them to the switch statements. And what match statement actually do, you can see on the first line, we define variable called number, which has value 3, and then we define match statement. And for each branch in the match statement, we define logic. So if the number is equal to 1, we will print 1. If it's equal to 2, we will print 2, and so on. And the last, 7th line is basically wildcard. So this pattern matches everything else. So for numbers 1 to 3, we print these three strings. And for all other values, we print other. The match statement can be used also, for example, for the enums. We will talk about the enums and structures a bit later. But yeah, the match statement can be also really helpful, for example, also for results and functions, but this will be also covered later in the lesson. Now let's talk about the functions. Functions in Rust are also pretty simple. You can see, the syntax starts with keyword fn, which stands for function. Then you have the function name. In this case, in the code on the screen, you can see we have two functions. The first one is called add. The second one is called square. Then we have the function parameters. In this case, you need to specify type for all of the parameters. Then we have the arrow. And after the arrow, you specify the return value. You do not need to specify the return value if the function does not return anything. If it returns anything, then you need to specify the type of the return. So in this case, we have a, or also, I would forget, you need to also specify types for the function parameters. So you can see the parameters a and b have also specified their types. So in this case, signed integers, both 32 bits long. And the result of the operation that is performed within the function is also going to be a signed integer 32 bits long. The small difference that I would like to point out in these two functions which are add and square is that in the first function you can actually explicitly tell that you want to return a plus b with the semicolon at the end, but you have the second option and you can specify it without the return and also without the semicolon. So you can see the square function takes the x, multiplies it by again by the x, so you create the square, and then this value evaluated is returned without specifying the return value, return keyword and the semicolon. So the idea is the same. You can also return from the function this way. And then on the remaining lines, for example, on the line 9 and 10, you can see that to the variable with the name result1, we assign the result of the addition. To the variable called result2, we assign result of square function, and then we print the values. In this case, the value 8 and 5, which are correct, as 5 plus 3 is 8 and 5 squared is 25. I think I told you everything about the functions, but I would like to also point out, if you have any questions and if you think that I missed anything, feel free to create feedback on the Discord or ping me into dev help and we can discuss that. All right, we went through the primitive data types as integers, signed, unsigned, also booleans. We went also through the arrays, tuples. Now I would like to have a look at custom data types, which are structures and enums. Enums are really similar to the unions in the C++. Structures, we might be able to compare them to classes. So let's continue to these two. From the perspective of structure, basically, as I was talking, it is similar to classes. The structure defines custom data types to group related data. So you can see on the code snippet that we have defined struct called user, and this struct is going to contain three fields, in this case username, which is string, then email, which is again string, and then active, which is boolean. You can even have nested structures or nested structures and enums, for example. So you can have structure which contains enum, you can have enums which contain structures, and so on. But yeah, as the definition says, it groups related data. So in this case, if you would like to define multiple data about the user, you can group the data into user struct, and it tells you the username of the user, email address, and if it's active. Then on the line 7, you can see how to actually create instance of user struct. So we create instance, which is actually the variable called user1, and then we create new object. So it is called user, then we specify the username, email, and active. So we create new instance of the struct user. You can see in the definition field of in the definition of the struct, you need to provide the types of fields. That's all from the structs. And now we can continue to the enums. As I stated, the enums are similar to the unions in the C++. So enum does not need to necessarily contain only simple variants, such as enum 1 to 3, for example, but the enums can also the enum variants can also contain values within each of the variant, and these variants does not need to necessarily have the same length. As you can see in the code on the first line, we have defined enum, which is called IP address or IP ADDR, and we have three variants that can be or that are contained in this enum. First one is v4, which inside contains 4 8 bits long unsigned integers. Then the v6, which contains string, or we have empty variant, which contains only the information about that the IP address is actually unknown. From the line 7, so 7, 8, and 9, on line 7, we create variable called home, which is IP ADDR, variant is v4, and we specify the values that are going to be included within this variant. For the v6, we have the string within the variant, and for the last one on line 9, which is the variable is called unknown, we just specify that we want this variant from the enum, and then there are no any associated data for that variant, or there are not any additional data stored within the variant. Now we can continue to the ownership and move semantics. There are few ownership rules. It starts with each value in Rust has a variable that's called its owner. So in the start, I was talking about the simple declaration of variables. So for example, we had let x equals 5. That means the value 5 is owned by the variable x. Every value in Rust have only a single owner. So that means the value 5 is owned only by is owned by only one owner, which is the variable x. We will talk about the references, which are views, which do not transfer ownership, but later in the lesson. And when the owner goes out of scope, you will see this on an example. When the owner goes out of scope, the value is dropped. What that means? Let's have a look at this code snippet. So on the first line, we specify variable s3, which is string, and it contains block string. Then we have created block, and within this block we specify new variable, which is S4, and the S3 value is moved to this new variable S4. Then we print the content of S4. I would like to mention that as the value is moved, the ownership changed. So currently, or on the first line, on the line 1, the owner of the string was variable S3. In the block, we move the owner of that string from S3 to S4. On the line 4, we print the content of the S4, and then, as the commands suggest, S4 is dropped here and the memory is freed. That's because the S4 variable goes out of scope as the block ended for the variable, where the variable S4 is declared in the block. So, and the block ends, that means we cannot access the variable out of the block. And the last line, the 6th line, and there is also the error suggestion. If you would like to try to print the content of S3, you will receive error as S3 is no longer valid, because, as I was talking on the previous slide, the last point, when the owner goes out of scope, the value is dropped. On the line 3, the owner was changed from variable S3 to the S4, and then after the block ended on the line 5, the S4 went out of scope. Alright? When the owner goes out of scope, the value is dropped. That means the string was dropped, so we cannot print the contents of S3. That's basic idea of ownership and the move semantics. Now, when we are talking about the ownership and the move semantics, we should also talk about the references and borrowing. I was talking about the ownership on the previous slide, and as we can move value, that means we can transfer ownership. But we have also something called references in Rust, which can be mutable and immutable. On the immutable reference, that's similar to the slices. So it is just view to the value stored in the variable. That means you are basically looking at the value without ability to modify it. For the purpose of the references, I prepared these two functions that you can see in the source code, or let's say pseudocode. But if you copy it into the playground, it will you can run it, but you need to also include the main function. The first function is called calculate length. It accepts the string, but notice that we have the ampersand before the string, and it returns usize, which is basically primitive data type. It stands for the pointer-sized unsigned integer type. But it is not important for this example. Just understand that we are returning number. And within this function, we have s.len, which returns, this is function specified for the length in the std, and this function returns the length of the string. As I was talking about, the immutable reference, it is just a view, or we are having a look at the value without ability to modify it. So we just look at the string with the reference. So important to mention is that the reference does not transfer ownership. So as I was talking about the ownership, let's say you have a variable called, in this case, the variable is called, you can see it on the line 5. The variable is called S1, and this variable has ownership over the string. Then on the line 6, we call calculate length, but we do not transfer ownership of the value of the string to the new variable, that is parameter of the function. We just tell it that here it is, you can read it, but you cannot modify it, and I'm still owner, I mean the S1. And yeah, in the function, we check what is the length of the string, and we return this value, or the number of characters. then we can have also mutable references. So we have the function on line 9, which is called change. And you can see we do not have only ampersand there, but we have also mute keyword. That means if we have a look at the line 13, the S is defined as mutable variable. This variable is owner over the string with the content of hello. And on the line 14, we are calling the change function, and we are saying, all right, take the value which is string hello. We are passing it to you as mutable reference. So that means we are still owner. We, I mean the S variable. We are still owner, but you can change the content of the string within your function. In this case, within the change function. And as you can see in the change function, we take the string S and we push comma word to the string. So it is again mutable or immutable view on the value. References are used really often in the or during the programming in Rust. As you do not transfer ownership, you can just specify that, hey variable, have a look at this. You can read the value, you can check what are the characteristics of the value, but do not change it. Or you can also specify the mutable reference, which can also change the value. But important thing, not to forget, that references do not transfer ownership. All right, now let's move on to the traits, which are particularly helpful with connection to the structures. So let's continue. In traits, you define shared behavior. Similar, you may know it from the different programming languages as interfaces. So again, the pseudocode, we define trait called summary, which have specified function called summarize, and it takes reference to the self. So that means if we define trait for some struct, the self means we can access fields of the struct, and it returns string and then comma. This is basic syntax, or sorry, semicolon. I would like to mention for the trait or traits that you can have specified default behavior for the trait functions. In this case, we do not have specified the default behavior for summarize, but if you would like to specify the default behavior for some of the functions defined in the trait, you just specify the body of the function. All right, and we can continue to the struct. So we define on line 5 struct called article, and it has two fields: headline, type of string, content, again, type of string. And then on the line 10, we specify impl for, or in this case, implement summary. I will tell it in the common language. Implement summary for article. So that means for this structure, we would like to implement the summary trait, which specifies or defines, contains function called summarize. If we have multiple functions in the summary trait, we need to define, or we need to implement every function for the article struct. If some of the functions in the summary trait have default behavior already specified in the summary trait, that means we do not need to necessarily override the behavior, the body of the function. But if the body of the function is not specified, we need to specify it. In this case, what we do is that we take, as you can see, the reference to self, and then we take content, and from the content, we take first 50 values from the string. The format is just macro. This is kind of a bit advanced, but yeah, the macro will just construct the string from the accessed from the content. In this case, it is slice. So we are just reading first 50 values from the content string. That was all for the traits, and now let's move to the lifetimes. Firstly, the lifetime prevent dangling references by specifying how long references should be valid. So yeah, that means as in the definition we have the word references. That means the lifetimes are tied to the references, and it is also tied to ownership. So if you can see that in the code snippet we have again a defined function, in this case with the name longest. Then we have the a lifetime, and then we have two variables or two parameters, sorry, not variables but parameters, x and y. In this case the x is str reference with the lifetime a, and the same goes for the epsilon. What is important is that we also return the reference with this lifetime, and the type is str. The function performs check that if the x is longer than epsilon, we return the x a slice or str, and if the epsilon is longer, then we return the epsilon. And now let's go to the line 9. So we have here defined the string1 variable, which is owner over the string with the content long string is long. Then we have variable called result. We do not assign any value to this variable, which is okay and all right. And then we go into the block. On line 12, we create a second string with the content short, and we assign value to the result based on if the first string is longer or if the second string is longer. What's the problem here? Or I want to describe the lifetime. So if we go through out of the block, so on the line 14 we go out of the block, so the string 2 is actually dropped because the string 2 went out of the scope, as we were talking about the ownership and moving semantics. In this case, the lifetime specifies how long should the reference live. In the function definition on line 1, we have specified that the lifetime a is both for x and epsilon. That means that the reference should be active for both values for the same period of time. That means when the x is available, then epsilon is available, and if the epsilon is available, also x should be available. But it is not ensured on the line 15. That's why it will throw an error. Because on the line 15, we would like to access or print the content of variable result, but the result variable went already out of scope because the return value of the longest of the function called longest has also specified this lifetime. That means after the block on the line 14, the string 2, which is not long or which is not longer than the string 1, but went out of scope on the line 14, so the lifetime was not ensured because on the line 15, the string 1 still lives as it does, or it did not went through the out of scope yet, but the string 2 already went out of the scope as it was dropped after the block ended on line 14. So hopefully this was understandable. I would like to describe it in more simple ways. As I was talking about the references, and that the reference is basically mutable or immutable view at the value, you can look at it in similar ways. That means with lifetime, you basically specify that the underlying value should live for some period of time. In this case, we have specified that both of the variables should live for the same period of time, but it is not ensured because the string 2 is dropped after the block ended, because the variable went out of scope. Now, let's move to the error handling. In error handling, I would like to talk about the two concepts that are available in Rust. And the first concept is actually called result, and the second concept is called option. So again, we have specified function, which is called divide. It accepts two parameters. Both are floats. Parameters are called a and b. And the return value currently is not just a primitive data type, for example, F64, but we have specified here that we would like to return result. In this case, we have also two parameters for the result. First one is first one is F64, so that will be the result of the division, and the second one is string. And what's the idea here? So the idea is that if b, as we are performing division, if b is equal to 0, we cannot divide by 0, so we can return result. In this case, the result is error, so that's the second part of the result definition on the line 1. So we create string division by 0 and we return this value. In case b is not equal to 0, we actually can divide and we return result of this division, but wrapped in OK, as you can see on line 5. So basically, you are telling in the function definition that you would like to, again, return result. If some conditions are not met, we will return some kind of error message. In this case, we have string, which specifies that which tells us that the b is equal to 0. If the conditions are met, then we return the OK with the result within the OK. So this is the idea behind the results. Then the second are options. Options have two possible values. As again, also results have two possible values. So the first one is actually the result value wrapped in OK. The second one is the error message. For the options, we have the final value wrapped in sum, or the none value, or the none option. You can see we have again specified function which takes character and reference to a string. So in this case, we have slice or reference str type, and then we return the option. What this function performs is that it loops through the characters of S. The enumerate actually also returns the index on which we currently are. So you can see we specify on line 2 that for E and character or character, and we loop through the characters of S. If character is equal to the C, which is input parameter of the function, then we return sum with the index where the character was found. And if we loop through the whole string and we do not find any value, we do not find any character that is that is the same as the C, then we return none. You can also use options not just on return types of functions, but if you would like to, for example, specify optional parameters of function, you can specify it as option, and in case you do not want to pass anything as a parameter on input, you just specify none. or you can specify sum with the included value within. So that's all from the error handling, as I was talking about two possible options, which are errors and options. And then, errors and options, a result and option. And now we can move to the project structure. In project structure, I would like to talk about the packages, crates, and the modules in order for you to better describe the folder layout of Rust programs. So first thing is crate. So the crate is the smallest compilation unit in Rust, and it can be either binary or library. Binary crate generates an executable program like main.rs, and library crate is reusable library basically. You can see the definition cargo new, definition how to create new binary. So cargo new my project or cargo new my library with the specified flags, in this case bin or lib. Crate can contain then multiple modules. So yeah, we have package, we have crates, and we have module. Crate can then contain multiple modules that organize the code. You will see the folder structure in a few slides as I prepared image for that. Then we can have package. Package contains one or more crates, and it always has a cargo toml file that describes the packages, dependencies, and metadata. In the small picture on the right hand side, you can see that what can be the contents of cargo toml file. So we have the first part is the definition or the metadata of package. So in this case, name, version, and edition. And then we have specified the dependencies, which we would like to use in our package or in our crates, in our code. And that's, in this case, random and the version of the desired crate. Now let's continue to the modules. So modules are used to organize code within a crate. So you can have multiple, as I was talking about it during the crates, you can have multiple modules specified within one crate. It lets you split code into multiple files, or you can even have nested, for example, modules. You can have multiple modules in one file. So it basically lets you to split the code into multiple modules based on the logic of code. It is defined with the keyword mod, and for example, you can have public modules or private modules, or you can have modules that are public only for the desired crate, and so on. And finally, this is the structure. So you can see it also starts with the package. Then the package can have multiple crates, in this case binary or library. And then in this in the crate you can have module 1, module 2, module X. And also you can have submodules, as I was talking about recursive or nested modules. So that means even module can have additional modules. If you want to see this more in practice, for example, Trident is one package that contains multiple crates, for example, CLI, client, and fast. And then we have also specified multiple modules and submodules, for example, in the client crate, where we have split code based on the logic. So this was just the small or quick addition to the project or folder layout for the folder structure for you to understand. But as I said, small addition. Again, I wouldn't necessarily say that this is really, really important for the Solana development, but it might be helpful for you to better understand the structure of projects. And now I would like to move to the really quick hands-on example to show you how to actually start coding in the Rust. We won't perform any, we won't create any sophisticated programs, but just the quick intro how to initialize Rust programs. All right, you can see let me clear the terminal, you can see the VS Code, which comes with the Docker image. I was talking about this at the start. For those who are wondering what is this environment, if you go to the School of Solana repository or scan the QR code, I think it was in the second slide of the lesson, then you can find the Docker image also with the instructions how to install the Docker image in your computer. This has the Rust pre-installed, also the Solana CLI, and also the Anchor framework. So it will be also helpful for the later lessons and the later tasks. But now I would like to show you, I showed you the Rust playground, but it is nice for playing, but I would say for more sophisticated programs, bigger programs, it is great to write them locally, or at least from my point, but it is individual. So I would like to show you how to actually create new Rust program, new hello world, and how to actually execute the program. So we will start. Let me type the command. In this case, we need to specify cargo, new, and hello world. Press enter. You can see that the cargo actually created new folder with the cargo.toml file, which specifies that this is package. And then we have the crate dedicated to the main dot or containing the main.rs. And you can see that this source file contains one simple function called main, which prints hello world. You do not need to specify anything else. You can just go back to the terminal, navigate to the hello world or to the newly generated package or the program, and call cargo run. You can see it ran the binary or the source code and printed the hello world. Obviously, you can play with the source code. So, for example, you can define, for example, function and perform additional stuff in the function. I won't write currently the function or the source code. You can take the examples from the lesson and you can try it by yourself in this environment or in the Rust playground. The second thing that I find really helpful is the Rust analyzer that is also included in the Docker image. So for example, if you would like to see the description of the, for example, in this case of the print line macro, you can just hover over the macro and it will show you the description. Second thing is if you would like to, if you have more or bigger code base, more sophisticated source code, you can hold Control and click, for example, on the variable, and it will tell you where is it defined. If you have the macro like this and click on the macro with the while holding the Control, then you can see where the macro is defined. So this is really, again, helpful during the process of creating new Solana programs, or for example, just the Rust programs. So I showed you how to create new Rust source code, how to create new Rust program, and how to run the Rust program. That's all from the hands-on example. This was really quick hands-on example, so hopefully it was helpful. And now I would like to move back to these slides. This was all from this lesson about the introduction into the Rust programming language. I hope you learned something new. This will be definitely helpful for the later stages of the Solana programming. As I said at the start, Rust is the main programming language on the Solana, but also on the other blockchains. But this can be helpful also during development process on other blockchains. And yeah, I hope you enjoyed the lesson. I would like to thank you for the attention. I would like to hear your feedback. If you have anything that was not clearly described, feel free to ask in the dev help. If you would like to add anything, feel free to give us the feedback on the Discord, and we can improve the lessons for later students. I also enjoyed the lesson, and see you in the lesson 3. Bye.